Good morning, everybody. Welcome to our webinar today. The topic is Fronius battery management. My name is Hans Pelzer. I'm guiding you through this presentation today, and which will take roughly about 30 minutes. And beside me is also Robert Reinbrich from our team. He will answer your questions during this presentation. So feel free, as you know, to send your questions and we will answer them immediately. Following points are planned for this webinar. Basically, first I'd like to show you what you need for a battery management solution, so the battery storage system, basically the basic requirements for it. Then I'd like to introduce you the feature, how to adjust the battery management options and features on the Gen24 inverters. Then also some suggested solutions which we can recommend for you, what you can do with this, and also the commissioning steps, how to achieve these solutions. Basically, at the end, we like to give you a very rough calculation of the savings which you can achieve when you use this option. Before I start, I would like to have a short question to you. And if you maybe could give me an answer, you can also choose more answers. What is in your countries? Do you have flexible energy tariffs at some of your customers? Do you have a high energy costs? Would you say you have also high energy costs? Do you have feed-in limitations on some of your customers? And do you have several grid outages probably per year in your country? So this is, I think, please choose the answers. Give me your feedback, what suits to your customers and to your requirements of your country. And I would like to get this feedback from you, because this is quite important for me to see how important the different features are for you. So we have already now nearly 50% feedback. Yeah, I'll wait another few seconds, and then maybe if you can choose again whatever it suits to you, which answer is best for you. Okay, I'll get now a bit more than 50%. Good. I think we can close it. Thank you very much for your feedback. And I also would like to show you that. So it's most of you have feed-in limitations, the issue with the feed-in limitation, but also all the other answers are there, of course, with high energy costs, with flexible energy tariffs, and also with grid outages. Especially the first point, that the flexible energy tariffs is very important for us for this presentation, because this gives good opportunities to increase your your return of investment. You improve your return of investment of your PV system. So basically, when you start, what is required for a basic Fronius battery storage solution? You need the Fronius Gen24 inverters, SIMO Primo, with a different type of batteries. Usually, mainly we're using BYD batteries so far, the HVS 5.1 to HVM 22.1, and also new, the LG Resoflex is now available with also a power class or capacity class from 8.6 to 17.2 kilowatt hours. Also with the SIMO hybrid, we could do the same as we explained today. I will focus today on the Gen24, but you have similar settings as well with the SIMO hybrid inverter, with the BYD battery HVM 8.3 to 22.1 kilowatt hour. If we see the main advantage, basically, maybe from our systems, it is the multi-flow technology. And with the multi-flow technology, we have the possibility to store surplus energy in the battery, as well to do the battery charging during backup power mode. Also, we achieve quite high power, up to 9 kilowatt, and this is also, I think, a big advantage. But beside that is another two things very important. We can also integrate existing inverters or other producers or generators, as well as we can charge from grid power. So the Gen24 can also charge the battery from the AC side if necessary. And this is actually the point where we discussed today what to do with this feature. So if we continue, what's the battery charging from grid? What we want to do with achieve with this? We would like to overcome high electricity tariff times, basically. With a variable electricity tariff and therefore mostly cheaper nighttime tariffs, we can use this feature to charge the battery at nighttime with cheap energy and use it at the high electricity tariffs in the morning or on the next day. Especially this feature is very important in winter time, because in winter time we don't have enough energy from our PV system to charge the battery, usually full. So therefore the battery is maybe only charged with a very low percentage, only SOC of maybe 10, 20, 30%. And of course that's not enough. Also for more security in the event of a power outage, it could be good if you have your battery always at a certain level be charged. And this is also, when you do that with cheap night energy, it's also an advantage that you have always a little bit higher SOC values. Also, with higher feed-in yields of the PV system, it can be achieved. Yeah, when you have feed-in limitations, you can also use it for this feature. So that's a time of use feature, or battery-dependent battery control, time-dependent battery control from our inverters. There are also some possible disadvantages when you do so. When you charge a battery at nighttime, of course, you have a little bit more charging cycles, so they will be slightly increased. You have also a low charge and discharge losses, of course 5 to 7% losses you have to expect. So when you charge at night and you use the energy, and the next day you will lose about 5 to 7% of this energy. And the customer should probably also be able to activate the function winter and deactivate it in springtime, for example. Reason is that in springtime, when we have enough PV power, we don't need to charge again at nighttime because the battery is still nearly full probably, and so it makes no sense to charge again at nighttime. So therefore, we recommend to deactivate this feature in springtime as soon as you have enough sun that you use that feature mainly only in winter time. Good. So therefore, if we come to the energy tariffs, and this is now the daily, one-day energy tariffs from the stock exchange, from the stock market in Europe, where we see how the energy price is in every hour. Example here in the morning hours from 1 to 4 a.m. we have energy tariff below 16 euro cents. If we compare the price from the morning hours from 8 to 10 a.m., which is about 25 euro cents, so roughly about 9-10 euro cents higher. And also another one during daytime it's a bit higher, and also again in the evening hours, especially from 5 to 7, it's also usually higher, between 25 euro cents as well here. So of course this will change every day. This is a very typical day from January this year. And we will see that there is no big difference from the days. It's just a little bit different on the weekends, especially on the Sundays, where we see a smaller increase of these energy tariffs, which is here just about 2 euro cents from the night tariff to the day tariffs. It would be a bit higher in the later evening, so let's say from 5 to 8 p.m. Then we will also see here a little bit higher difference. But it's usually, that's very, very common, that you will see on the weekends the difference is slower. During the week, the difference is higher. And it can be higher than this year. It can be some days we have also difference of more than 20 euro cents from the morning to the evening. Good. So if we see now this feature, I would now explain this time of use feature more detailed. We have different possibilities to set this feature. Basically, first of all, you can adjust the maximum charging and discharging limits. So you could say, for my battery, I never want to charge and discharge my battery with more than 2 kilowatt or less than 2 kilowatt discharging, or higher than 2 kilowatt discharging. You can set two values in the web interface to limit this power, and can achieve some advantages with this. Another point is a specific charging range, so from 500 watt to 3 kilowatt, for example. Also here you need to set two values, a minimum charging and a maximum charging power. Another setting is the same with the discharging, so discharging range, which you can set. Another possibility with specifying a defined charging power. So you always want to charge with 2 kilowatt, for example. Then you need also to set this value exactly, a minimum charging power and a maximum charging power according to this exactly power. Same also with discharging. Again, you can also use this. So these are some examples which you just to see what you can do. So you limit your battery charging, or you can also set the charging to a certain range, what you want to do with the battery. So if we now look into the activation of the feature, we have here the possibility to set first of all in the device configuration. So when you do the first commissioning of the inverter, you have to also when you activate the battery, you also allow the battery charging from public grid, because we need that in this case, because we need to charge our battery, for example, at nighttime from AC grid. Therefore, we need to activate that here. This is the first thing you need to do. And secondly, under energy management, in the settings of the web interface, you will find the point battery management. And under battery management, you will then see that there is, first of all, no data included. But if you click on the first point, you can adjust a maximum charging power, minimum charging power, maximum discharge power, or minimum discharge power. As well, you can set here, beside the power, so which power you would like to charge, for example, and the time, from what time till what time, and also the day, Monday to Sunday. So on which days you would like to activate these time-dependent battery control. And of course, you can set as much parameters here as you want. You can set different parameters. The parameters cannot be changed for the months. It's only possible for the weekdays, Monday to Sunday. That means you have that every week the same parameters. The charging and discharging power, what else is important? If you set the power to a certain value, you always should make sure that you have a certain maximum charging power as well. When we charge the battery from the AC side, we can charge first of all up to a maximum power of the inverter, AC power. So for example, a 5 kilowatt inverter can charge with 5 kilowatt. But you also have to know that it's also depending on the battery what maximum power we can achieve, because the battery voltage is different from if you have, for example, 2 modules HVS or 4 module HVS battery, which is from 200 volts to 400 volts. And with the 400 volts, of course, you achieve higher power. And with 200 volts, we achieve only half of this power. So please make sure that you always take that into consideration. And here is again the average power range of the different inverters with the different batteries. So for example, you have a HVS 5.1, you can achieve only 4.5 kilowatt with a GEN24 10 kilowatt, because the voltage is limiting this power. If you have a 5 kilowatt inverter, you have only 2.5 kilowatt charging or discharging power. With the bigger batteries, the HVS 10.2, you can achieve the 5 and 9 kilowatt power with the BYD battery. On the LG, it's very similar. There's no big difference. Basically, you see here it's about 500 watt difference, but not a big difference. So please make sure, don't forget these. Otherwise, if you would set here high power and you wonder why you cannot achieve this high power, then of course it is depending on the battery and probably as well on the inverter, which is limiting this charging and discharging power. Good. I would now go into the solutions, and here I'd like to start with the first one, the low night tariffs. So we have, for example, a case, wintertime, low energy tariffs from 1 to 4 a.m. And we would like to use this time to charge our battery. So we would like to cover especially the next day, morning hours with this battery capacity. What I need to do in this case is only to set the minimum charging power to, for example, 2 kilowatt in a time from 1 to 4 a.m. And I'd like to do that during the week only, because on the weekend I will have probably not a big difference between night and day tariff. Of course, this is also now depending a little bit on the battery capacity you have. In this case, we have 3 hours charging with 2 kilowatt, means I have a 6 kilowatt hour battery charging. If I have a 10 kilowatt hour battery, I could also increase the power to probably 3 kilowatt. And then I would also have here a nearly full battery at nighttime, in the morning. So that's a little bit also depending on the battery here. Also, you don't need a full capacity as well. You can also choose to lower a little bit the power because it's maybe just important for the morning hours. And then you would have probably, again, a little bit of sun to charge the battery anyway at daytime. So therefore, it is not needed to charge with very high power. So this is the first, probably most important settings, which I can recommend you to do, because you also have here another advantage. As we said before, you have a certain battery capacity charged every day, and with this you have also for your grid outage a reserve capacity in your battery, and you can also use this when there is on the next day any grid outage. Use this power then. How does it look like? In SolarWeb, you will see the charging of the battery. We have now adjusted it from 1 to 4, and you see the SOC value goes up from 1 at the low percentage of, let's say, about 5% SOC to 100% in these 3 hours. It's a 6 kilowatt hour battery, and the battery will be charged until here we have achieved this 100%. It's a bit before 4 a.m. in the morning. And then we discharge the battery. We use our all consumption of the day, and the battery is then probably empty again anywhere at night. So we have used here our night energy, cheap energy, night energy for our day consumption. What you probably need to know is you would not see the consumption here in the blue color. I've here done, yes, you see in black color, the energy consumption which goes to the battery, but you will not see that in SolarWeb. Reason is that we have not the right, that we cannot show the right parameters in energy balance, because this is energy what you use exactly on the next day for your consumption again. And basically, if we would show here another consumption, we would need to reduce the day consumption. Otherwise, it will not show the right parameters in SolarWeb. We're working on a solution probably next to show this a little bit better in another view, that you can also see the nighttime charging. Now another example is feed-in limitation. If you have a feed-in limitation, let's say of 4 kilowatt, and you have your 8 kilowatt PV system, as an example, we should of course not charge the battery early in the morning, because if we start it in the morning, we would then need to reduce the feed-in power for lunchtime. So let's say from 11 to 4 o'clock, I would need to limit the feed-in power, and I would like to avoid this. So therefore, I set the time-dependent battery control to a level that we will not charge before 11. So when I achieve this 4 kilowatt feed-in power, then I charge at the moment, then I start to charge the battery. You see also the SOC value will then also increase to charge the battery. When the battery is full, we have then that at a later time. In this moment, it is about nearly 2 p.m. in the afternoon. What I can also do, of course, is I can set the charging power, I limit the charging power to 4 kilowatt. So maximum charging power to 4 kilowatt. That means I will never charge more than 4 kilowatt. So if the power would go higher than this 4 kilowatt, I would have some feed-in. Yeah, and so unfortunately, I didn't find the right picture here in SolarWeb. But if you imagine the power is higher from the PV system, the battery will only be charged with 4 kilowatt or a lower power. But in this case, you will never feed in more than this 4 kilowatt to the grid automatically, because we use the other power for our battery. Of course, when you have, like in this example, an on pilot to produce hot water, the hot water generation could then start, and also the watt pilot in violet color could then start also to avoid any feed-in limitation. So you have different options here to play with and to avoid feed-in limitations in that perspective that you have to limit the output power of the inverter. In this case, we don't limit at all. We use our power a little bit later, and we use a little bit less charging power to avoid this case. So that can be helpful. Of course, it's a little bit a question to find out the right settings for your battery size and for your feed-in limitations. So this should be just an example how to do that. Now another example is for I have a watt pilot. I'm charging the battery. I'm charging the car at nighttime because I'm arriving in anywhere in the evening, let's say 6 p.m. And of course, if I want to charge it, I could set it to 11 kilowatt, and the battery in this case would then be discharged within, let's say, 1 hour. It's 11 kilowatt battery. You charge with 11 kilowatt, and the battery would immediately be discharged. And probably you don't like to do that because you would also like to benefit from the high night tariffs, energy tariffs, that you have your battery also for other loads at the day. And probably also you would like to limit the power here. In this perspective, you can also set the minimum discharge power to, for example, 3 kilowatt for the whole nighttime from 6 to 6 o'clock in the morning. And with that, you will never discharge a battery too fast, and you will probably have, even in the morning, still some capacity left, or also for a grid outage battery capacity left to avoid these problems here. Of course, you can also limit the watt per load in this case to limit the power, but also you probably have other high power load, a heat pump or whatever, which is discharging the battery within 1-2 hours, and you would like to have to use your battery for the whole night as well, probably in the next day morning. So this is also possible to set. Yeah, and the last point here is how to save battery capacity for grid outages. When you would like to just reserve a capacity, you can also do the settings under in Webinterface, where you set up the inverter under function and IOs, the point where you set the backup power, PV point or full backup, and the last point here is the reserve capacity. So this capacity, if we set it in this example to 7%, or if it is set it to 20%, for example, will never be used for anything. Just in the moment of a grid outage, you can use it. So it would probably also make sense, of course, here to set this reserve capacity to a certain value, because with that you always make sure that you have something left in the battery for a grid outage moment. But it's up to you, however you would like to use it. Use it with the battery management feature or use it with the reserve capacity. Good. Last but not least, we have done a very rough calculation of the savings. We have chosen the last couple of months since November, so the wintertime months in Austria. We have a 10 kilowatt hour battery with a 10 kilowatt PV system, average energy price of 10 euro cents difference from day to night. So this is what we have calculated over the last 3 months, and that means this is the difference from nighttime 1 to 4 a.m. to the morning hours between 8 and 10 a.m. in the morning. So with that, you achieve on about roughly 60 days this advantage, because these are the days when you have the big difference. And if you calculate that with these 10 kilowatt hours energy price of 10 euro cents, you will achieve about roughly 60 euro savings per year. And also additionally, some higher feed-in tariff is expected, of course, because you would then probably also have on the next day, if it's a sunny day, some more feed-in power. If you have high feed-in tariff, of course, this can be also an advantage. So this is very much depending now in which situation you are. If you have high feed-in tariffs, then it's good. If you have low feed-in tariffs, then you probably would need to charge the battery not too much at night time to avoid feed-in on the next day, or your feed-in limitation as well. Make sure that you use your power in the morning on the next day, which you charge at night time, to avoid overcharging of the battery. Good. Now, further information. We have a document attached. Sorry, I think it's not included now. I will need to send you that tomorrow. Also, you will receive the video of this recording of this webinar tomorrow. You can watch it again and see how you do the settings. In the document, we have a very detailed description how you do what are the advantages. Also, a very detailed economic calculation is included in this document. Feel free to use this. It's a white paper, time of use, and we can also, as I said, we will forward that to you the next days. Also, we have other webinars and trainings, of course, with battery storage training online and face-to-face, where you can see this, and some other videos on our Fronius YouTube channel. So now I'd like to go to your questions, and therefore probably I would like to ask Robert, maybe you can explain me or answer a few of the most important questions right now. Robert, can you hear me?
Yes, I can hear you. Many thanks for the interesting webinar and the interesting topic you brought up. So I get all the questions from you in. So there was really good questions also here. So I will sum up, I would say, the 2 or 3 most important questions. So one would be what I can do with an EV charge, the EV charging during the night hours, so that the storage is not empty in 1 or 2 hours. I think you mentioned it already, some slides before, but what would be your suggestions to if you combine this battery management with EV charging?
Robert, as we said, I think you can limit the discharging power of the battery. This is one possibility. Of course, you can also limit the watt per load with the charging power at nighttime. So these are the 2, I think, most important possibilities you can use in this case.
Many things. I also think reducing the charging power, discharging power, is a great option, because then loading with 11 kilowatts is still possible with the watt per load if it's needed. So then you get the rest from the grid, which is not if you not wanted to get it from the storage. Many things. Another question would be if we load the storage with 10 kilowatt hours, we have also some losses inside the storage because it's an electrochemical process. You can only use them at the moment, I would say, roughly at about 9.2 or 9.5 kilowatt hours out of it. So please, if you do any calculations, think about the efficiency of the storage also, because 10%, or I would say 9.5%, are losses if you charge and discharge them. But also, Hans, you mentioned it already in the very beginning of the webinar. And
yeah, make sure that you don't mix up the kilowatt hours with the kilowatt. So we have a 9 kilowatt maximum charging power and discharging power. But of course, you can charge for more hours to achieve the full capacity, to charge the battery full capacity. That's clear. So
for sure. Many thanks. And I think that were the most interesting questions. So I would also say we will stay some minutes here still in the webinar. So if you have any further question, we will write you the answers in the chat directly.
Exactly. Thank you, Robert. Perfect. Yeah. So we stay online with you. I would like then to switch off my microphone now, and hope it was interesting for you. Wish you a good day and good luck, and hope to see you once again on our next webinars. Thank you very much. Goodbye.